So now we're moving into the next section of tools of geometry, which is measuring segments. And here we're going to find our first named postulate, which is the ruler postulate, or postulate 1,5. It states that every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point. So in our illustration here, you can see that point A is located at -5. -5 is the coordinate of that point. Point B is located at 3, so that makes 3 the coordinate for B. If we want to measure the distance between the two, we can do that. Before we move on to actually measuring the distance, we need to do the naming convention. So the way that we name distance is by using two capital letters representing both points, and then those are put right next to each other with nothing on top of it. So no bar, no arrow, no double-headed arrow. And then the formula that we're going to use for this is AB equals the absolute value of A minus B, or the distance between A and B is equal to the absolute value of A minus B. We're going to take a look at question number 1, which is measuring segment lengths. Now, the first step in doing this is we've got to choose the correct formula, and you're going to find out in geometry, a lot of geometry is just picking the correct formula. You got to figure out what it is that you're working with, and then which formula is going to get you to your conclusion. So the formula that we want to use here is the distance formula, which is, again, AB equals the absolute value of A minus B. All we're going to do now is substitute any known values in for what we've got here. So we know that we're looking for ST, or the distance between ST. S is located at -4, and T is located at 8. So we want to put into our formula, ST is equal to the absolute value of -4 minus 8. So -4 minus 8 is -12. The absolute value of -12 is 12. And so that means that ST is equal to 12. Our next postulate is the segment addition postulate. This states if 3 points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC, or the distance between A and B plus the distance between B and C is equal to the distance between A and C. And you can see on our example here that that's exactly what happens. We can drop down that AB segment and we can drop down that BC segment, and we can see that if we combine them together, we end up with something that looks like AC. Problem number 2, using the segment addition postulate. In this problem, we're given if EG equals 59, what are EF and FG? And EF is given the value of 8x minus 14, and FG is given the value 4x plus 1. So what we want to do is we want to take those two quantities and we want to add them together and set them equal to what we know is the distance for EG, which is 59. So we know EG is 59. We know EF plus FG equals EG by the segment addition postulate. So we're just going to substitute our quantities in for EF and FG. So we get 8x minus 14 plus 4x plus 1 equals 59. Combine like terms, you end up with 12x minus 13 equals 59. Add the 13 to both sides, you end up with 12x equals 72. Divide by 12, and we get x equals 6. To figure out what exactly the distance between EF and F and G are, we're just going to take 6 and substitute those back into our original quantities. So 8 times 6, 48. Minus 14 is 34. 4 times 6, 24, plus 1 is 25. So EF is equal to 34, FG is equal to 25. Here we are in problem number 3, and we're going to look to see if we can establish congruency between segments. Congruent segments are simply segments that are the same length. The question here is, are segment AC and segment BD congruent? So the question we need to ask ourselves is the distance between AC equal to the distance between BD? Now, whenever we deal with congruency, we're going to be dealing with segments. Whenever we're talking about equality, we're looking at distance. So that's why you're going to see congruency symbols in some places and equality signs in other places. So if we again start out with AC equals BD, we're going to replace those segments with the formula for distance. So for AC, it's going to be the absolute value of A minus C. And then for BD on the other side of the equal sign, we're going to do the absolute value of B minus D. So we have the absolute value of A minus C equals the absolute value of B minus D. Now we simply substitute in the values that we have. So the value of A is -2, so we plug that in for A. The value of C is 5, so we plug that in for C. B is 3, D is 10. So we now have the absolute value of -2 minus 5 equals the absolute value of 3 minus 10. If we work those out, -2 minus 5 is -7, 3 minus 10 is -7. Now we take the absolute value of each one of those. The absolute value of -7 is 7, and the absolute value of -7 is 7. So we end up with 7 equals 7, which tells us segment AC is in fact congruent to segment BD. In this final question, we're given the information that Q is the midpoint of segment PR. So we're asked to find out what are PQ, QR, and PR. If we know that Q is the midpoint of PR, we know that Q lies directly in the center between P and R, which means that the distance between P and Q and the distance between Q and R are equal. So the first thing that we want to do is we want to go ahead and throw in those congruency markings so that we remember this. Now, since this is basically a 2 or 3 step question, that's not really going to be hugely important to go ahead and put those in, but you're going to get to 15, 20, 25 step questions later on in the year when you're going to need to be marking everything up so that you remember what you've already done in the past. Since Q is the midpoint of the segment PR, we do know that PQ is equal to QR. And what this now means is that the quantities that we're given for PQ and QR are also equal to each other. So we can write in 6x minus 7 equals 5x plus 1. What we're going to do now is, again, this is my recommendation. Whichever x value has the smaller coefficient, move that x value over. So we're going to move the 5x to the left side of the equation. And that's going to keep our x positive. It just means we have one less step to do at the very end. So by moving the 5x over, we end up with x minus 7 equals 1. Add 7 to both sides, and you get x equals 8. So now what we've got to do is we've got to find out what are the lengths of PQ and QR, and then also the cumulative length to get PR. What we'll do here is substitute the 8 in for x. So 6 times 8 is 48. Minus 7, and that gives us 41. That means that QR should also be 41. So what we're doing here by plugging this in, we're checking to make sure that we do have the correct x value. If we get 2 different answers here, then that means that we messed something up somewhere along the way, and we need to go back, we need to check our math or check our steps. So 5 times 8 is 40, plus 1 gives us 41. So we have that PQ is equal to QR. We know that that's correct. Now to get PR, we just add those two together. So PR equals PQ plus QR. 41 plus 41 gives us 82.